Okay, we're going to do number 43 on page 148 in your book. I have a picture up here. There's not really a picture in your book, but basically we have a 5 kilogram, it says a 5 kilogram bucket of water is raised from a well by a rope. If the upward acceleration of the bucket is 3 meters per second squared, find the force exerted by the rope on the bucket. So basically what we're trying to find here is tension. And we know the acceleration on the bucket upward is A equals 3.0 meters per second squared. So what we need to do, that's a picture I got from another book. All we need to do is draw a force diagram. How many forces are on this bucket? That's the question. Well, we have tension upwards, right? And we have mg, or weight, downward. And that's going to equal 5.0 kilograms. Remember, we use 10 meters per second squared in this chapter. And so it's going to be 50.0 newtons. This is a 5 kilogram bucket. So, if we are accelerating upward, if this bucket is accelerating upward at 3 meters per second squared, I want you to think, you answer this yourself. Is tension bigger than, smaller than, or equal to 50 newtons? What do you think? Well, for it to accelerate upwards with 3 meters per second squared, that means it must have a net force. Well, to have a net force, that means tension must be bigger. So we use Newton's second law here, and that is the sum of the forces equals the net force, which we have because we're accelerating, and that equals ma. So what I'm going to do is I'm going to start out by doing some of the forces. So in your mind, answer this. What I do with T and tension, which is just a letter that stands for a number, that's the force of the rope on the bucket, tension, and 50 newtons. What I do with those two? Well, they're opposite directions, so I subtract them. So it's going to be T minus 50 newtons. Down is negative, up is positive. Right, equals 50 newtons, or minus 50 newtons, equals M. Well, what's M? That's 5 kilograms times A. What's A? Well, they gave us that as 3.0 meters per second squared. And so T is going to equal about 64 newtons up. That's what T is going to equal if we solve this. And actually, we're going to get, what, 65 here, not 64. You know why? Because the 64 is the book's answer. It's because we're using 10 and not 9.8. All right, that's the answer to that one.